We've been designing networks for years, and usually how this gets done is that we try to create a network that can do anything and be able to accommodate any application. But the truth is that all applications are different, and they all have different requirements. And a lot of times we just think of applications as things like Microsoft Exchange, or a website, or SAP, or Oracle, when in truth, anything that touches the network and generates traffic is really some sort of application. So when we take a look at things like Active Directory and IP-based storage traffic and your VMware traffic, those are actually some of the most important traffic types on the network, because if I can't get to my storage, then my application sure doesn't work. And when I talk about these applications, as I mentioned before, they all have different requirements for connectivity, for security, for quality of service, and then what type of layer 4 through 7 services they use. So when we designed ACI, we thought, how can we bridge the gap between network language and application language, between network language and security language, between operations and applications? And what we came up with is it would be great to custom design the network for every individual application that runs on it, to have custom service level agreements almost for every individual application that runs on it. So we know that Exchange needs to get priority over my intranet website, but it doesn't get priority over my Oracle application. On top of that, we need to be able to apply security from end to end. Companies are looking for a different model that actually creates a zero trust architecture. They pretty much want it to the point where there's a firewall built into the network, because it's costing companies a lot of money when they have security breaches, when they go outside of their regulatory compliance. And so with ACI, we built just that. We basically have a layer 4 firewall built into the network, where you literally can't talk from one device to another without you first designing a security policy that allows that, if that's what you wish to do. We also rethought how we would configure the network if we could kind of do it all over again. We thought, wouldn't it be nice if we didn't have to worry as much about VLANs and IP addressing and routing tables? Wouldn't it be nice if we could just take devices and put them into groups, and then we just tell the network how this group of devices is allowed to talk to that group of devices? And that's exactly what we do with ACI. Break our devices up into groups. A group could be a VLAN. VLAN 10 and VLAN 20 are two different groups, and then we control how they talk to each other through our contracts. A group could be all of my Exchange servers and all of my SAP servers, and then we control who has access to the Exchange servers through our contracts and who has access to the SAP servers through our contracts. We can get very granular with our groups, like in the bottom of this web page, where we can say, I actually want to divide my application up into different groups, and I want to say that this web application consists of web servers and application servers and database servers, and I want to control how those groups of devices interact with each other and which layer 4 through 7 services they use at each hop. And I want to control which quality of service is assigned at each hop. And by building in that security from end to end and saying that the web servers can only talk to the app servers and app servers can only talk to the database servers, I've made my network much more secure than it is today, where anybody can talk to anybody as long as they have a route to get to it. So ACI fundamentally changes the way that we configure our network. And when we define that one policy for how web servers should act on the network, no matter where we plug that web server in, if it's a physical server, or no matter which host that virtual server relies on, they get that policy as soon as we see the traffic. We also integrate into the different virtualization vendors out there. So we can integrate with VMware, we can integrate with Microsoft, we can integrate with OpenStack, and we can actually push that policy down into those virtualization platforms and apply it right at the host. We can actually make those servers easier to configure so that all you have to do is choose the port group that is associated with your web servers, and then you get all the policies, and you get all the quality of service, and you get all the access to the devices that you're supposed to get. And we're reusing known good policy over and over again. So we're reducing the amount of human error. And we create the policy once, and it gets pushed out to all my devices, no matter if I have 4 devices or 20 devices on my network. And then once I create the policy, the best part is I actually start tracking the health of that application on an individual application by application basis, or on an individual VLAN by VLAN basis. So if I see an issue with VLAN 10, the system will alert me, and I can start troubleshooting VLAN 10 right away. Please join me for the next lesson, 9.6, Examining Network-Centric Mode.